If I'll try to make this simple, to talk about a working day of my life, what you'll see in this screen was an air handling unit display on a HMI. This is an air handling unit, and guys, you'll see we have heat exchangers. Heat exchangers are cooling and heating the air. So what you have to understand, if the air is moving through a heat exchanger, the air will be cooled or heated. And even if you use a chiller or a boiler in an industrial or commercial environment, you use pressurization units. They monitor the pressure and they make sure that they will compensate the amount of heating or cooling agent that is lost in a controlled environment. The pressurization unit is nothing but a box. If you look to it, you understand too much. This pressurization unit, usually it is connected to the main water supply, and also you have to fit a valve in case you want to disconnect it. Maybe you have to repair it sometime. Inside you have a water tank that have an overflow in case the floating valve is broken, and you'll have a water fill system. They have a valve too in case you want to repair the pressurization unit. The bypass is used when you fill the installation from the first time, or when the pumps of the pressurization unit are faulty. And what you will see here now, on the top you'll see the water tank with the water flow and the floating valve. And to the bottom you will see two pumps, and they're equipped with non-return valves. Onto the tank you will also see the high level and low level probes. Make sure you will system will alarm if you have too much water or no water into the water tank. If we move further, we'll start building our installation. When we'll attach the pressurization unit to a system, we have to make sure that we integrate a pressure vessel. The pressure vessel will allow us to keep the pressure constant or to minimize the pressure variation. I'll explain this to you later on. Now I choose to use a heating system. Obviously what you will see here, it is a boiler. We all know boilers are used to heat a heating agent. So the heat from the boiler, it's transported by heating agent, and for this we need pumps and pipes. Now we connected the pressurization unit to the system, and we have to continue our journey to build our installation. You will see I continue to build my pipes. I put valves because maybe I want to segregate part of the system. And finally I put one radiators. But guys, the installation could be bigger. I only show you one radiators because I want to simplify the way I explained, so you'll understand very easy what happened. Now we all know that in the beginning the tank is empty. Inside the pressurization unit there's no water into the system. We check all the system. If everything is okay, we check the motors, we check the electrical connection. Technically we check everything to make sure that our installation it is safe and sound. Now the first thing to do when we want to fill our installation is to open the valve of the main cold water supply. We open the valve and we have the time to check the leaks. Now the tank will fill up. As you'll see, the floating valve will allow the tank to fill up, and then the water will be restricted to go from the main cold water supply's floating valve into the tank. Then you make sure you don't have leaks and everything is okay. You can put the lid back, and then you'll continue the journey. You'll open all the valves into your installations. When you fill the tank for the first time, obviously you will turn on the bypass valves. You don't want to stress the pressurization system pumps. It's pointless. And also you will open the purge valve. You will see near the boiler It's a little valve that it's changing the color between red to yellow, so you'll have a complete circuit. You only eliminate all the air. Obviously, the system will be provided with air eliminators that will remove the rest of the air in the installation. So you fill the system with water, and once you're satisfied, you will turn off the bypass valve, and then you'll turn on the pressurization unit, which will take over, will control the pressure, and it will fill the system in a very controlled environment. The set point is chosen by you according to your installation demands. In this case, let's say I fill my system with 0.8 bars. So when the water is cold, I have 0.8 bars. And I start the pump to circulate the heating agent through the system, but I'm not starting the boiler yet. I want to make sure all the air will be eliminated through these air eliminators. Could be in some places pockets of air, and I just want to make sure my installation is properly filled and I don't have air into the installation. Finally, probably the last step, it is for me to enable the boiler, and then the installation start to heat up, and you'll see the pressure vessel rubber bellow inside shrink. We all know that when the temperature increase, the heating agent will try to expand, and that pressure vessel will allow a quantity of heating agent to go inside. You just saw that the rubber bellow shrunk, and this is the way installation works. But if you're unlucky enough and your rubber bellow will be damaged inside the pressure vessel, then we'll start to have a little bit of problem, because when you'll hit the installation, there won't be any elasticity. The heating agent cannot migrate inside the pressure vessel, it's already full, and the pressure will reach the point where the pressure release valve will allow the water to go out. Enough quantity of water will go out until the pressure will stabilize just below the PRV maximum allowed pressure, and then the PRV will stop. That's why when you turn to the premises too late, you will only see the water on the floor, you won't see the PRV leaking. This is okay, but in the morning, because you lost too much water, when the heating agent will cool down, you have only 0.2 bars into the installation, and the pump will run to compensate the heating agent that you lost. And that's okay, but then you will really abuse these pumps. They will work every day to compensate the water you lose, and sometime you might damage one pump. If you damage a pump, an alarm will be triggered. You will see this alarm on the display of the pressurization unit, and the second pump will fill the system. It's no any problem, and you'll have a healthy system. Again, 0.8 bars, your system will run beautifully, and you'll be happy. But when the heating agent will heat again, you start losing water again, because you never fix the pressure vessel, which doesn't help. And after you lose enough quantity of water, obviously the heating system will run. You'll have a flooded service floor or plant room. In the morning, obviously the pressure will drop again, and the pressurization will compensate again. But let's say you're unlucky, both pumps will die to one pump. Both pumps will be damaged. Then you have to drive to your clients and to use the manual bypass. But can you imagine you have to do this every day? I don't think your manager will be happy to pay £100 in diesel, so you drive to fill the system every day. And that will be something which will create massive hassle. That's why you have to be very careful with your colleagues. Sometimes they play heroes, they tell nobody the pumps are broken. So you fill the system again manually, and then the second day you start losing water again, no elasticity into the system, pressure raises too much, and the PRV allows the water to go out. And then the system obviously stabilizes, you run for the day because you can't lose water anymore. Until the second day, when obviously overnight, when nobody uses the installation, the pressure will drop again. And then if you have both pumps damaged, the pressurization unit obviously is not working. You will fill the system again just to satisfy your customer, and until you repair the pumps, technically you cannot do too much. But if you repair the pump without replacing or repairing the pressure vessel, then you will have a repeated fault, and that's not good either for the customer or for you. This is about the pressurization unit and the importance of the pressure vessel. Just watch my other videos. I have some video which explain more in detail how the pressurization works, how the pressure vessel works. And in the end, I just want to wish you a great week and see you next time. Thank you so much and goodbye.